So, good afternoon, everybody. Myself, Acharya Vishvendra. This is NCRT line-to-line discussion of Chapter 14, Semiconductor Electronics. Let's start with next question. So, it says that in an isolated atom, energy of any electron is decided by its own nucleus or nucleus of other atom. So, it is in isolated state, so it is influenced by only its nucleus. So, first is correct. Next is nature of electron motion in an atom is similar to electron motion in a solid. Very different. It's very different than in a solid, because in a solid an electron is influenced by other nucleus also. So second is correct over here. Next is inside a solid crystal, each electron has a unique position, each electron has a similar position. So if we talk about a crystal, then inside the crystal each electron has a. So the next question is, each electron in a crystal has different energy level because no two electrons see the same pattern of surrounding charges. So first is correct over here. Next is energy bands are formed due to, obviously due to different energy level of electrons. So first is correct over here. Next is valence band includes energy level of, so these include energy levels of valence electrons. Next is the energy band above the valence band is called, it is called the conduction band. First is correct. Next is with no external energy, all valence electrons will reside in, obviously in valence band. So first is correct over here. Next is if lowest level of conduction band is lower than highest level of valence band, then electrons from valence band can move, obviously they can move. Next is normally the conduction band is empty for metals, insulators, semiconductors. So obviously insulators and semiconductors are generally non-conducting, so conduction band is empty for them. So fourth will be correct. Next is when conduction band overlaps with valence band, the materials are called, so certainly they are called the metals. So first is correct. Next is in insulators, valence and conduction band overlaps, obviously they have certain energy gap due to which electrons are not able to conduct. So second will be correct over here. Next is when an electron moves from valence to the conduction band. When an electron moves from valence band to the conduction band, there is possibility of conduction. Obviously, there is possibility of conduction in the conduction band. Next is for silicon, the outermost orbit is. So outermost is third orbit, as evident from the electronic configuration of that. So it's in the third orbit, the first is correct. Next is for germanium, outermost orbit is, so this is the fourth orbit, so second is correct. Next is for a sample of silicon, germanium crystal containing n atoms, total number of valence electrons are. So in third orbit, so obviously the electronic configuration corresponds to 1s2, 2s2, 2p, 6 and 3s2 and 3p, 3p2. So in the outermost shell there are 4 valence electrons for one atom. So corresponding to n atoms there will be a total of 4 n states. And as we know that the total energy states available to a single electron are 8. So the total energy states are 8n. So for this question answer will be 4n, and for this it will be 8n. Now another question is, in the above question the 8n discrete energy levels can form continuous band or can be grouped in different bands. So certainly both are possible, so third is correct. Next is at the distance between atoms of silicon and germanium crystal, energy band of electron is split into. So obviously it splits into two parts. So third is correct. And in the above question, the lower energy band is called. So this is called the valence band, whereas highest energy band is called the conduction band. Next is at absolute zero. All the electron are in for semiconductors. So certainly they are in valence band, as at absolute zero no energy is available to the electrons. However, for conductors there exist certain things called as Fermi levels. So they do possess certain energy and can conduct even at absolute zero. Next is conduction band at 0 Kelvin is for semiconductors. It is completely empty. So second is correct over here. Next is electron energy of different atoms are same when atoms are isolated. So the electron energy of different atoms are same when obviously atoms are isolated, so that no two atoms can influence electrons of each other. So first is correct. Next is when atoms combine to form crystals, maximum interaction is felt by obviously the outermost electrons feel the maximum interaction. Then we have in a sample of n silicon atoms, total number of electrons in the outer shell is, so these will be 4n. So next is maximum possible number, so that will be 8n. Next is empty states are so obviously s states. So s orbits are fully filled, so these are p states only, because s states are fully filled, they have 2 electrons. So p states have empty states over here. Next is as large distances, energy levels of atoms in silicon crystal is shown by. So if distance is large, then certainly there will be a splitted energy level, and it is given by 1 for large separation. Next is in the above question, energy of all electrons in same energy state is same in. So this can be decomposed into 4 regions. So this state corresponds to region A. So region A is correct over here. Next is in the above question, energy of electrons form energy bands. So they form energy bands obviously in region B. So the region B corresponds to this band formation. This is your region B. So 2 is correct over here. Next is in the above question, energy of electrons form energy bands. So in region B and C, so energy band, energy of electrons form energy band. So these are in region B and region C and D. So 4 will be correct over here. Next is different energy bands overlap. So these overlap in region C. Third is correct over here. Next is in region C, energy gap exists between upper level, does not exist because they overlaps. Next is in conduction band there are no electrons, 2n electrons or 4n electrons. So in conduction band there are 4n electrons. Similarly in valence band also there are 4n electrons. And in region D, valence band is completely filled or completely empty. So in region D,